Hello, welcome back to the channel. So let's continue our previous video and do one more question on solving indefinite or definite integrals using partial fractions. So again in this case, you see those factored out terms in the denominator, and you can clearly notice in this case as well that you have an x minus 3 times x squared plus 1 expression over here, and you know that these are factored out terms which cannot be factorized further, so you know that it might be easier for you to use partial fractions in order to solve this integral over here rather than using any other approach that we learned so far in order to calculate those indefinite or definite integral expressions, right? So that is why if you have not watched my previous video where we have covered in detail about how we identify that we have to use partial fractions to solve these type of integrals, I would highly suggest you to first watch those videos in order to get the full context of this video. So again, we identified the same pattern that we used to identify in the partial fraction questions cases. So we know that we have to solve this integral using partial fractions, and we also know how to convert this form into individual fraction components, right? So we know that the expression that we have over here is 12x plus 4 upon x minus 3 times x squared plus 1, and we know that the terms that we have in the denominator, the factored terms that we have, cannot be factorized further. So we know how to convert these type of denominator expressions into individual parts, which can be easily simplified to simply taking a upon x minus 3 for this term over here, and for this term we will write plus bx plus c upon x squared plus 1, right? Because we have an x squared term over here which is a quadratic expression, and that too cannot be factorized further. So that is why we take, so whatever highest power we have in the denominator for that expression which cannot be factorized further, we take a polynomial of 1 degree lesser than the polynomial in the denominator for the numerator case. So that is why, since in this case your highest degree of the polynomial in this factored out term was 2, so that is why we took a linear polynomial in the numerator for that specific denominator case, right? Again, we have already covered this concept in detail in the previous videos, so that is why I highly suggest you to watch those previous videos in order to get the full idea of why we converted this expression to this expression over here. And now we know that we can easily solve our a, b and c by just comparing the numerator on the left hand side to the numerator on the right hand side. So let's do that. We know that this term, the left hand side term, would be equal to a times x squared plus 1 plus bx plus c times x minus 3 upon x minus 3 times x squared plus 1, right? And now let's solve for this numerator over here. This would simply be ax squared plus a plus bx times x minus 3 plus c times x minus 3 over here, right? And the denominator will again be the same thing. So now let's only compare the numerator on the left hand side with the numerator on the right hand side, just to get the values of our a, b and c in this case. So we know that 12x plus 4 would be equal to ax squared plus a plus bx squared minus 3bx plus cx minus 3c over here, right? And now let's simplify this expression by taking the common terms together in this case. So we'll take the coefficient of x squared first. So the coefficient of x squared would be a plus b, and that's it, right? So a from here and b from here. And now let's take the x term over here. So the x term would have minus 3b plus c over here, right? And for the constants, we have plus a minus 3c in this case. And the left hand side is this one, so we can easily compare the left hand side with the right hand side coefficients. And now by comparison, we know that there is no x squared term on the left hand side, so the coefficient of x squared is 0, minus 3b plus c is equal to 12, and a minus 3c is equal to 4 in this case, right? So from this expression, a is equal to minus b, and then if a is equal to minus b, we know that minus 3b plus c is 12. A can be written as minus b for the third equation over here. So this would be transformed to minus b minus 3c equals 4. And now you can solve for these two linear equations over here, right? These two linear equations with two variables. So if you solve these two linear equations over here, you can multiply this expression with 3. So if you multiply this expression with 3, it would become minus 3b minus 9c and 12 over here, right? So you can now subtract both of these equations. If you subtract both of these equations, you know that this would be 0. This would become plus, plus and minus. So this would become 10c over here, and then this is 0. So 10c is equal to 0, which means your c is equal to 0. And then if your c is equal to 0, you know that minus 3b is equal to 12. So b is equal to minus 4. And since a is minus b, a would be equal to 4 in this case, right? So now we have solved for our a, b and c. And now we can easily convert our original integral expression into a simpler form. So since we had to calculate the integral of this expression over here, we know that it got easily simplified to a upon x minus 3. Your a is 4, so a upon x minus 3 plus bx plus c upon x squared plus 1, right? So b is minus 4 and your c is equal to 0 in this case. C is 0, b is minus 4. So the second term was bx plus c upon x squared plus 1. So you have an x squared plus 1 in the denominator, and for the numerator you have bx plus c, b is minus 4, so it would be minus 4x plus c, c is 0 in this case. So that is why your expression, and you're taking indefinite integrals as well, so that is why your expression will be simplified to simply calculating 4 times the integral of 1 upon x minus 3 dx minus 4 times the integral of x upon x squared plus 1 dx in this case, right? And now you know that you can easily solve for both of these indefinite integrals. You can use this integral would simply be natural log of absolute value of x minus 3, and you can easily solve this integral over here using substitution. So I'll leave the integral calculations to you, and I would highly appreciate if you can comment down in this video the answer to this indefinite integral expression over here. So that's it for this video. Again, the main takeaway from this video is that whenever you have factored out terms in your denominator, you know that you have to use partial fractions in order to simplify your integral expression into a much simpler form by breaking down that expression into multiple individual components, for which you already know the integral of those multiple individual components, right? So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.